The Sieve of Eratosthenes is an ancient algorithm for finding all prime numbers up to a given limit. Since 1 is not considered a prime number, let's remove it from the list. We start with number 2, which is the only even prime number, and mark all multiples of 2 up to 100. The next unmarked number is 3, which is also a prime. We mark all multiples of 3 up to 100. The next unmarked number is 5, the next prime. We mark all multiples of 5 up to 100. Then comes 7, the next unmarked number and a prime. We mark all multiples of 7 up to 100. At this point, we stop. You'll notice that some numbers are marked by more than one prime. For example, 30 is the product of 2, 3, and 5. It gets marked multiple times during the process. However, this redundancy doesn't significantly affect the performance of the algorithm. Now, we remove all the marked numbers, and we are left with the prime numbers up to 100.
Let's understand why we don't need to check for prime numbers greater than 10. Consider the prime number 11. 22 is a multiple of 11, but also divisible by 2. It was already marked. 33 is a multiple of 11, but divisible by 3, already marked. 44 is divisible by 2. 55 is divisible by 5. 66 is divisible by both 2 and 3. 77 is divisible by 7. 88 is divisible by 2. 99 is divisible by 3. 110 is divisible by both 2 and 5. Finally, 121 is the first number that is divisible only by 11, but it's greater than 100, so it's outside our range. So we don't need to check primes greater than the square root of 100. In general, we only need to sieve using prime numbers up to the square root of n. Since the square root of 100 is 10, we only check the primes less than or equal to 10. That is, 2, 3, 5, and 7.